Is my open source project safe? This is a continuation of research that I was presented last year at RSA, looking into terrible things you can do with GitHub, and then extending that into GitHub Actions. So there will be some easy stuff to go through that I'll skip that you'll already know, so I can catch up and make up time. Here's the obligatory image of me. Cloud security advocate. I have like so many titles at Palo, depending on who I'm talking to. I've been writing code since an embarrassingly young age. And I was heavily into Kubernetes and containers for a long time. I think I mentioned, I did the hand raise. I was the only CKS apparently in the building. Yay, that's reassuring. And if you ever find yourself in London, in England, which is actually where I live, I run a meetup there called DevSecOps London. I like beer. I have a YouTube channel about it. All right. I know the answer to this. It's all of you, right? And I also know this is a whole open source conference. Perfect. This is really in here for the OWASP people, but it's fine. So I'm going to talk a little bit about GitHub Actions. Hands up if you already know what they are, and I can blast through this and make up time. Fantastic. Just to double down the fact that they all come from a marketplace, and we seem to implicitly trust everything that comes from this marketplace. And there is 19,000 different options of wonderful things you can do with actions in this space. Who would possibly think about compromising anything in this marketplace? Keep that in mind. All right, potential attack vectors. Known methods that we did in this research, one's called repojacking, other one is npm email hijacking, another one is command injection. I'm going to show you a few examples of these. I'm going to describe repojacking first, though, because it's kind of complicated for GitHub Actions specifically. Just to let you know, we analyzed 7,000 repositories, but in the research for this, of 30,000 that we scanned to see if they were using GitHub Actions. So this is where the research comes from. Repojacking, all right. Say you've got a GitHub repository, and you move it. So you know, like the U, so mine is Eurogig, and that becomes a namespace, and the repository has a name. Those together are a namespace in GitHub. If you say you got bought, and they acquired you, and they want your amazing open source tool to be somewhere else, then that's fine. You move it to a new org, and GitHub will happily redirect for you. So anyone who's dependent on your previous repository and is cloning the previous one, it will pull from the new one that's being updated. This is a cool feature. You can even delete it, and it still works. Now, then you run into a problem if you delete it, because then I can come along, and I can just try and steal it. Now, GitHub has a precaution here. So if they will retire the namespace entirely if there's been more than 100 clones in the week leading to the account being deleted. So if it's still active and you're still cloning it, it will then say no one can ever have this again. The forward will be forever. Job done, totally secure. Yeah? A total of 100 clones in the week before you get rid of it. The problem is that if it's a GitHub Action repo, and you pull that action, it's not a clone. So that could be a super busy, being used, forwarded GitHub action that is there. It's just an asset. It's like an artifact. It's not a clone. So this doesn't work on GitHub Action forwarding. So I can create a new action repository, and I can become malicious. This is actually what we did. So npm email hijacking, if you don't know what that is, it is the parse the package lock of a JSON repository. This is how you script it. You go get that example. This one actually works, and pipe it to JQ, and you will get the email of the maintainer of that project. You then go to see if they still exist. In that particular one, I actually don't think it is. And you can buy it, sub mail server, reset the password, and become the owner of the project and put whatever you want in there. You can just script this, and it works great. npm does check up periodically to see if domains don't exist. And if they do, they prevent it. But if you're on it and you're constantly checking, you can find these things, which is good. Command injection, you might already know this one. This is an example of searching through GitHub for people who are using GitHub metadata. Here it's GitHub event issue title. A little bit of regex to see if the title makes sense. Adheres to my amazing standards. Unless I create an issue, you'd be surprised how long an issue title you can create. I will blast through this. Right, anyway. I did this as an example of where I have two personas, and I intentionally get someone else to add the issue check YAML to someone else's repo as a helpful addition to the repository. And then, then I got a friend who looks suspiciously also like me to paste in exactly what I just did. Now, I like that you get to see it. This is where I would have typed it, but I went and got and pasted it. We all understand the power of backticks? Awesome. And that's webhook. You just go there, and that URL will just receive anything you want. It's great from a hacker perspective. So there we go. All those weird characters were totally fine. It runs issue title check. And presto, I have everything. So that's the first one, and this is probably. All right, other things we can do. I can do dependency confusion. If you know what that is, I just create a dependency that looks like another dependency and hope you download it. Doesn't work that often. The malicious pull request or poison pipeline execution is great because if I submit, you probably know this, if I submit a workflow as part of my pull request, there's only if I'm not a previous contributor will it not run that workflow, even before you've approved it. If I'm not, it even says in the help, be careful if my submission is in the GitHub workflows directory, because it will say, do you want to approve and run? And if you don't have this, it actually scolds you for not clicking approve and run, because it says, what? All the security stuff's in approve. Surely you want to run your workflows, not considering that I've just submitted a workflow that will run. So you ideally should have the second one checked, but the default is the middle one. So what I do is I change the README, I submit my workflow, and anything I want runs. If your repository is older than February last year, anybody have a GitHub repository that they created before February last year? All right. The GitHub token has pretty much full rights to do everything. They changed it in February to be read-only by default. This is a good thing. This is exactly because of this research. This is an example of a pull request that approves itself. Hurrah. Because you can do that. The only thing you really can't do with a GitHub token before that is actually merge your own pull request. It's like one of the only things you can't do. This is another example. And we'll see if I have to get this in the video to work again. Maybe if I do the permission myself, I can. We'll see. This is an example where I'm exporting the secrets. I'm curling the secrets to the same place. Same environment variable command that worked before. And then this thing. Anyone recognize this? Weird command with lots of covering my own tracks. That's a reverse shell. All right, I'll talk you through it. Remember I said I had two personas? The white screen was the good guy, the black is the bad person. This is an account I have called Loud Canadian. And the same person that created issue check. So I'm creating a suspicious workflow called pwn.yaml. I wouldn't recommend being so obvious. And I'm going to paste the whole thing in there. And you can see in this, I have both. I have my auto approve, and I've also got all three of these nasties down here. It's kind of too bad they didn't run this straight out of Google, because I actually trimmed a lot of stuff off the front of this to make it faster, which is totally. I can't commit to main because it's a protected branch. That's good. I'm going to create a new innocent workflow and send all that in. So I'm running netcat up here on a particular port. You know what I mean when I'm doing that? I'm waiting, right? It's very much like webhook.site. I'm waiting for somebody to connect to me. If we could see the bottom of that reverse shell, you'll also see that it has a 32 port connected to it. So I have submitted. That's my workflow. You will see the approval, which has been approved by my good friend, the GitHub butt. Which is interesting, it's hidden. Because if you came in, that's the whole point. If it looks auto-approved, because you only have one approver, and by the way, branch protection only has one approver by default. You have to choose two. I've got the GitHub token from the secret. Could have had all sorts of other secrets in there, right? I would have got them all. By the way, there's two ways to get secrets. One like that, and another by dumping memory. It's very easy to download a memory dump, get the memory dump from the runner, and pull all the secrets out of it, even if they've not been used. So now I'm on the runner. And I'm going to make myself look a little bit prettier. You can see I'm on runner at, this is GitHub's property. Cool. So then I'm going to show you that the PR is still active. You can see it's just stuck. It's open. And I'm going to run a few. If you're really fast, you can see what I'm doing. Come on, Steve, go back. All right. I'm not going to unpack that, but it's a lot of weird things. But you notice what I've done is my PR is closed. The files I changed are not there, so there's a bug. I can try and look at what happened, and I can see, okay, well, it does see it, but it's not showing what the changes were. So I can't look inside pwn.yaml anymore, because it's vanished. And I click through, and the only commit, go back, isn't from me anymore. And that's if you don't use signed commits. You can change your identity to any email. If it recognizes it, it even puts the picture up. It's not secure. So these are the different methods that you can use to attack. I haven't even got to the whole point of the new research yet, but this is the old research. So this was pretty fun. This was done at, oh God, all right, I forgot about this bit. I'm runner, on the runner. For the container enthusiasts, do you know the magic Docker command if you want to just go straight to root? Well, you will in a moment. Clear doesn't work, I remember this. I recorded it, I didn't want to re-record after that didn't work. Run privilege net host, PID host, IPC host, everything host, busybox, and I'm out. And now I'm root on the GitHub runner. That's fun. If you know Rory McCoon, I got that from him. He's really good with Kubernetes security. Yay, you've all learned terrible things. All right, what if my target isn't vulnerable? Actions have dependencies, so I can start looking at whether you have an action and whether your action has an action. And I can start thinking about those attack vectors on those. And this is what we did. We created an actions dependency tree of those 7,000 repositories, which were with a goal of doing this. Compromising one action to compromise another action to compromise another one to attack repositories that weren't vulnerable. The 7,000 came from the top 10,000 starred GitHub repositories, and because we're greedy, 32,000 repos of companies that had bug bounties. We filtered out the ones that didn't have GitHub Actions, hence 7,000, cloned the repo, checked for the attack vectors, stole the tokens and all the available secrets, checked to see if those tokens had permissions, like the permissions we're talking about, and looped it. We found one repo that allowed us to attack 18 intermediate repos that allowed us to attack 72 repositories of the 7,000 we were after, and that's just one example. This has already been disclosed, so it's not new. One action was used by Veracode, another very good security company, but they had an action that was used by 1,600 public repositories and countless private repositories. Veracode was used by Hangfire, and that action, Hangfire, produced a NuGet package that was downloaded by nearly 10,000 people, and we were able to modify. We showed how we could modify and own that NuGet package using this research. How did it really work? We attacked this one repository. We got the GitHub token, and then we changed this particular action. When this action was used by this action, it downloaded the same, and then we overwrote the v1 reference, so we changed the commit. You can force commit over a existing commit that is tied to a particular tag. So we didn't have to do anything. We just changed an existing commit to be our malicious material. So essentially we created a worm that once we affected the first one way upstream, every time those actions triggered, it rewrote things all the way down the line until we got to the final vector. And I'm not going to do this. Please don't. Good. So you said at 10 minutes. I have a demo where it shows that. And instead, I'll tell you to come to Lisbon in June, and you'll see the actual demonstration of how that works. But you get the idea is that all those different methods we had, that GitHub token that's highly vulnerable, the fact that the permissions were not manually set to read for older repos, they had branch protection rules that were not set correctly, they did not use protected tags, they did not limit outbound network connections, because in order for this to work, we had to reach out and grab our program that would then run the commit using the token and change the text. So we are also reaching out, and they were not protecting that. They were not pinning the actions using a hash. They were using a version number. So if you do all of these things, then none of these attacks will work. But unfortunately, many repositories in that top 10,000 don't do these things. And most of these, believe it or not, are in the documents, if we were to read security documents, which none of us do. Another way to do this, if you like open source, OpenSSF, another Linux Foundation, great people. The scorecard does check for a lot of these behaviors. So if you go get scorecard, run it on your repo, at least your repo will be safe. If you're really clever, you can script it, and you can get it to check the repos in your dependencies. Done, squeezed it in. This is the co-researcher, Assi Greenholz, who wrote the worm. It was brilliant. Took him a long time. Good, that's it, thanks.